Right. Hi, everyone. I would like to have the face-to-face class on this Thursday, but unfortunately, some of your seniors not able to come attend on Thursday, and so we have to have a blended learning this Thursday, and I will see you on Monday again. Hopefully, no more holiday on Monday. So back to the topic. Last week we have learned about discrete random variable, um, so binomial, multinomial, and we also learned about Poisson distribution. And I give you some of the example. You can try it out as well. Also an assignment for a group assignment. Some of you come to meet me for the assignment. You have some doubt. So again, please come to see me before the due. I won't extend the due. So yeah, for the assignment, you can upload them to two files. One is PDF, another one is the Excel file. So try it out. I have limited to two files. If you have problem, just let me know on that. So like this week, we are going to learn about continuous random variable. So I divided this chapter into two parts. One is about the probability density function. We're also going to learn about cumulative distribution function and also the expected value. And we learn about, the uniform probability distribution. So after that, next week, we will cover about normal probability distribution. This is one of the important chapter for this whole course. So I hope to see you on Monday. Yeah. So back to this, probably you have learned about this during your matrix, but let's have a look on that again. So continuous random variable, as we have discussed few weeks ago, continuous random variable, you have the range or you have the decimal point. For example, your height, your weight, the weight of a sensor, a weight of a coin cell. So it will change a little bit. It won't have integer. So those are called as continuous random variable. So like discrete random variable, probability density function do have some rules. So if the big F is cumulative density function. So before that, we look at the probability of PDF first. So same thing, your probability is between 0 to 1. If you have calculate and you found out your probability is more than 1 or negative, so you know something wrong with it. And your cumulative or your maximum probability is always 1. Okay, right. So the difference between the DRV and CRV is the CRV equal any one particular value is 0. For example, the probability of x equals to 0.2 is 0. So thus the two events, x bigger than 0.2 and or x bigger or equals to 0.2, they have same probability. Okay, so I did include a link in our Smart V3 to explain and show example on why this happened. Okay, so you can check it out on that part. It's quite similar to the DRV. The difference is if you want to find the DRV, so right, let's look at this diagram. So if you would like to know the x equals to 2, so the probability is 0.25 if you look at the graph on your left side. Okay, the right side is cumulative probability. So the discrete random variable x equals to 2, you can have a specific probability on that part. Right. Whereas for CRV, continuous, you can't find the x equals to, let's say this, in this case is x equals to the height of a woman. Y is the probability density on your left side, the graph, yeah? So if I would like to know the cumulative, right, if for the CRV, I would like to know the PDF for a value, it's 0, okay? So I have to find is either bigger on that value or smaller on that value. So back to our lecture notes, yeah? The CRV equals any one particular value is 0. Remember this. So for example, let CRVX denote the current measure in a thin copper wire in milliampere. Assume that the range of X is between 0 to 20 milliampere, and assume that the probability signature function is Fx equals to 0.05. So what is the probability that current measurements is less than 10 ampere? So in this case, it's quite simple. Let's have a look. I can draw it out. Okay. So I know that by drawing this out, Fx, okay, so we start from 0 to 20, and the x is milliampere, okay? So this is the Fx, this is the probability, this is 0.05. So what is the current measurement that is Px less than 10, less than 10? So this is 20, this is 0, this is 10. So less than 10. So therefore I have 10 to 0 x dx, and my Fx is 0.05 dx, and I have 0.05 x 10, and you should have 0.5. Okay, it's quite simple. So I give you another question. Example is, I would like to know x between 5 and 10. So what should you do? Same thing, very simple. Can I erase this? Okay, so I use the green color. So 5 is here. Now I would like to get the between 5 to 10. Same thing, P, X, 5, 10. And after that, 10, 5, and then 0.05 dx. So, and therefore, and you have 0.25. Is that simple enough? Right? So if you say, I would like to have the probability x equals to 5, then it will be 0. Why? Because based on this law, okay, so Px equals to a number is equals to 0. Okay, so you can try on this example, a hole drilled in a shaped metal component, and then a shaft is inserted through a hole. The shaft clearance is equal to the difference between the radius of the hole and the radius of the shaft. Let random variable x denote the clearance in millimeter. So this is the PDF of this continuous random variable. The component with clearance larger than 0.8 millimeter must be scrubbed. What is the proportion component are scrubbed? So what does that mean? This is meaning that, so probability X must be scrubbed. So we have larger than 0.8. What is the probability on that part? Right. So this is the equation. I forgot to write this. Okay. So if X more than 0.8 is scrubbed, so what is the probability that more than 0.8? So we know that the equation is given this one, okay? Solve it out. We have the equation 1.25x minus x power of 5 over 5. And we plug in the value, we should have this answer. It's quite straightforward and quite similar to the RV basically. Okay, so cumulative distribution function. Cumulative distribution function, the difference between them is actually very simple. Let me show you. Okay, this graph is actually, I get it from internet. So I think it's showing a very good example. For the left side is the BRV, for the right side is the CDF. So the CDF is cumulative. So we try to add together and then it becomes the cumulative at the end is 1. So let's have a look on this part. So for the probability density, I would like to look at less than 158. The probability is 0.25. Okay, and if I refer to CBF 0.25, and then actually I can get the same value 158. So in order to get your cumulative probability 0.25, your height shouldn't be lesser more than 158 centimeter. Okay, so right. So well, let's have a look on the discrete random variable that previously we have learned together. So let's say I throw the dice. The probability for me to get 1 is 0.2 because they are even. But when I convert it into CDF, it will 0.2 plus 0.2 is become 0.4. Plus 0.2 from the outcome of 3 is 0.6. So by accumulate them together, the total is 1. Okay. Right. This is same as the continuous random variable. So to get the S beautiful K curve from the bell curve, so we're actually doing the same thing. Okay? Understand? Do you understand on this part? Right. Best answer. Okay. The cumulative distribution for continuous random variable is a line, it's a blue line. Whereas for discrete random variable is a step because it's not, there's no meaning. For example, what is the probability for me to get 1.5 piece of cake, 1.5 piece of cake? Yes, you can have it. But what is the probability for me to get 1.5 handful? You can't cut the handful to half. So that is discrete random variable. So for if cake or the height, so it's keep on gradually increase. So that is CDF, the continuous random variable CDF. Okay, so let's all have a look on the this is the formula for us to write the cumulative distribution function. So we will say the big Fx is the probability getting the range of x value. So the shaded area is the Fx. Okay. Okay. Let's have a look on the example. This one. This example again. But this time I would like to draw the CFD and plot it out. So I can divide this part to 3 parts. Okay. One is because the question already given. Okay. So 0 to 1. Okay, this is x. The x I can more than 1. The x I can less than 0. So what is the CDF on this part? So as we know that the CDF that less than 1 is 0. Okay, because you never define that. The x between 0 to 1, there is a formula given, right? So we plug in the formula, okay? And so we don't forget that this is 0 because this is less than x less than 0, negative infinity, so it's less than 0, so it's 0. So for this part, right, so we have the formula given on this part, right? Plug it in, do the integration, and you can get your formula, which is between x to 0. So while x more than 1, we never have an equation to define it. It's not inside our range, and therefore this is 0. Okay. So if x more than 1, okay, x more than 1, because it's a cumulative, so I have 3 parts. Remember, this is a cumulative, so let's use the green color. So this is the lesser than 1. This is the x between 1 to 0. This is the bigger than 1, x bigger than 1, x 1 and 0. This is x smaller than 0, because this is cumulative. So we know this is 0. When I plug in the number 1 to 0, this is 1, and this is becomes 0, and therefore when x larger than 1 is always 1. And therefore I can write my fx into 3 parts. When x smaller than 0 is 0. When x between 1 and 0, it's this equation. When x bigger than 1, this is equals to 1. And if we combine this with this condition, clearance larger than 0.8 must be scrubbed. So I can draw my fx equals to this goal. Okay? Is that okay? So I'll give you an example, another test. If your probability less than 0.5, what is the cumulative? So because 0.5 is between 0 and 1, the x 0 and 1, and therefore you can directly use this equation. Where you get this equation, remember, we solve this equation from here to here, okay? And therefore your formula is this one. Plug in your 0.5, you're able to get your answer 0.617. Okay? So expected value is also called a mean. So like the discrete random variable, the difference is this is a formula because it's continuous. So the formula is quite similar like the discrete random variable. Whereas for the variance, the formula is actually the ex squared minus the mean power of 2. Okay. And this is the step to show you how they get the formula for the variance. Okay. So I will show you give you some exercise later so that you can practice and try to understand from the example. So if your sample, your variance has a constant, right? Have a constant. So your constant also equals to have to power of 2. This is some of the rules for the variance, right? So next is uniform probability distribution. Uniform probability distribution is something when you having the continuous, but your probability is constant within that range. Okay. So for uniform probability distribution, the function is always 1 over b minus a. Assume that we are looking at A to B. Okay, right. So why we get this? Let's have a look. So assume that I want to find the x between A and B. So it's always, the cumulative is always equals to 1 because I'm looking on that part only, right? So it's equals to fx times the x, the width, right? The height is the fx, the width is b minus a. So I know that the total here is 1, right? So I move this there, and therefore I have my fx equals to 1 minus b, 1 over b minus a. Okay, that is simple enough. Okay. Well, for those interested on how we derive the formula for the variance of CRV, I have shared the link on this YouTube in our Smart Retreat. Check it out later. It's quite informative. You can further listen to this Smart release to explain on that part. Right. Okay, so this is the 5 minutes workout. I would like you to try because the answer is given as well. So try it out and then we can discuss later. So probably we discuss together, but let's try and we will check it out. Let's try together. I might trick you. Check it out whether you get the same answer like me. So for example, when a motorist stops at a red light at a certain intersection, the waiting time for the light to turn green in seconds. It is uniform distributed on interval 3 to 30 seconds. Find the probability that its waiting time is between 10 to 15 seconds. So let's check it out. Right, so we know that quickly we can draw it out. This is actually start from 0 to 30, but we know that just now, I already explained to you why the fx is 1 over 30 minus 30 minus a b. So in this case, 30 minus 0, so 1 over 30. So I would like to find the probability between 10 to 15. So I just write the function is 1 over 30 because 1 over 30 minus 0 is 1 over 30. So then sort this out is x over 30 and the x is between 15 and 10. By plug it in, you should able to find the answer. So 15 over 30 minus 10 over 30. So it's equals to 5 over 30 equals to 1 over 6 seconds. Okay, so try it out later. Yeah. So I also give you a 5 minutes workout. It's quite fast and straightforward. We will discuss it on our next class. I do show you the an answer, but check it out and let me know if you have problem to understand it. And also the let's try. It's quite interesting on this part. It's not tricky enough, not tricky. It's quite straightforward for you to understand the uniform distribution. So I hope you understand this chapter, this part 1 for the CRV. I'll back to you on Monday for the normal probability distribution. So thank you. Bye.